to our workshop for financial math. Before I start doing some exercises, let's review some of the topics that we have been explaining up to this point. Take into consideration that in order to take financial decisions, there are fundamental variables to be reviewed. First of all, let's review about the flows. What about the flows? We can be referring to individual flows or multiple cash flows. When we refer to individual cash flows, we are going to have something like this: a single amount, right? Future value, present value, considering an interest rate of I and a time, let's say n. What is going to be, in this case, the present value? Present value is going to be equal to future value divided by 1 plus I to the n. In the same way, if we speak about present value multiplied by 1 plus I to the n is going to give us the future value. When we refer to multiple cash flow, we have two kinds of flows. We can be referring to some flows that have exactly the same amount. This case is known as annuities. Annuities will be something that looks like this. We want to find the present value of a flow that have identical amounts. That's the case when you receive a loan, you are asking for example, buying a house, you have to pay the same exactly amount every month. So in this case, the present value is going to be equal to the amount C divided by I multiplied by 1 plus I to the n. That's the present value. If you want to take it to future value, it will be the same, but you will have to multiply by 1 plus I to the n. So in this case, the future value is going to be exactly the same. That means C divided by I multiplied by 1 plus I to the n. And we will have to multiply one more time to 1 plus I to the n in order to take it to the future. But we can have some cases when the amounts are not the same. So this will look something like this. You want to find the present value, and you have different amounts. Let's say C1, C2, C3, C4 will look like this. In this case, what will be our present value is going to be C divided by 1 plus I to the n, and the present value is going to be the sum of these amounts. So we are going to put the present value is going to be the summation notation. Let's make it like this: summation notation of these cash flows that goes from 1 to time t, considering that we have here a time t. That's regarding the flows. What about when we refer to the time? So the second point will be what happened considering the timeline, the time. We can have two possibilities. We can be referring to finite time, something that will be exactly the same that we have been seeing here, because in all these cases, we have been reviewing something that ends in a period of time. So that's with finite flows. But we could also be looking to infinite flows. Infinite flows. In this case, our timeline will look like this, where I want to find the present value of a flow that goes forever to the infinite time. In this case, we can have something that will look more or less similar than the annuities with equal flows, C in all, but the difference will be that goes forever. In this case, the present value will be C divided by I. Another possibility when we refer to infinite flows is sometimes where you are doing some projections of your cash flows, you can consider a growth rate, for example, inflation. In that case, we will have a perpetuity that grows into the future. As the time passes by, the flows start growing. So the flow will be something like this, present value. In this case, the flows start growing with a G that is called the growth rate. In this case, the present value will be C divided by I minus G. And what happens when we refer to interest rate? We have, again, two possibilities. Regarding interest rates, we can be talking about simple interest rate or we can be referring to compounding interest rate. When we refer to compounding interest rate, please remember that we are going to use our formula that will be effective interest rate plus 1 is going to be equal to 1 plus our periodical interest rate. So interest rate of the period raised to the number of times we are going to cover in the complete period, to the end. Simple interest rate, we use also, in this case, nominal. It's called nominal interest rate. Okay? With these formulas, we have reviewed basically everything related to present value and future value. But when you take financial decisions, an additional two measurements need to be considered. One, the net present value, and the second one, the internal rate of return. The net present value will be the initial investment, usually with a negative sign, plus the present value of the future flows. In this case, speaking in a general way, is going to be the summation notations of the flows, cash flows, when n goes from 1 to t, as we saw before. The second one, the internal rate of return, that makes the net present value equal to 0. Net present value equal to 0. So in this case, what we are going to find is that I. If we use that formula, what we are going to do is that initial investment will be equal to the summation notation N1 to T, Cn, and in this case, this I is going to be the internal rate of return. And that will be our result. Remember that when we speak about internal rate of return, we are talking about rates, so this is going to be in a percentage sign, and when we talk about net present value, it's a value, so we are going to have amount. That will be the big difference. Now that we have worked all these formulas, doing exercise, using our calculator, we are going to go to the Excel functions because we can do all this resolving problem in an easy way using our different Excel functions. Let's go and check how are we going to work using Excel. And this has been the basic formula for financial math.